Hi, I'm Mr. V, and this is Illustrative Mathematics, Unit 2 on congruence. And today we're talking about Lesson 11, the side-side angle, sometimes congruence theorem. And so it works sometimes, but sometimes it doesn't work. And we're going to explore that today. By the end of the lesson, you should be able to say, I know side-side angle does not guarantee triangles are congruent. You should also be able to say, I know when it does guarantee that they are congruent. So the first thing we have are two figures. What do you notice? What do you wonder? And I'd like you to try to answer this. So spoiler alert, I'm going to tell you some things that students said already. Something they noticed. You have two pairs of corresponding sides are congruent, 4 and 5, 4 and 5. One pair of corresponding angles is congruent, 40 and 40. Segment DG, 4, is congruent to segment IK, which is 4. Segments of the same length are congruent. These triangles don't look like they're congruent. Some things students wondered, are these supposed to be congruent? Should two triangles with two pairs of congruent sides and a pair of congruent angles be congruent? Will this situation ever result in congruent triangles? What has to be true? Let's explore it. So in this next thing where it says dare to be more different, here's a video which explains what we're doing in this GeoGebra app, at least the first part of it. There's two parts to this. So I'm going to open it up so you can see it. And the first part of this is when you're going to try to use these sides to make a triangle and make as many different triangles as you can. And now notice if I put the long side here, I've got other options for the short side. I could make this side the short side. My angle is fixed. It's not changing. So there's different ways of doing it. You can watch my video and it'll show you how. And then we have this situation. And I'm going to make the one side 4 and the other side 3. And you'll notice here I've got a 43-degree angle. One side is 4, one side is 3. Now I don't know what this one is. I don't care about this one. But what I do know is that my outcomes, when I do this, I can move this here. What? There's two different versions of this. I can do two different versions of this. What if I switch these lengths? Because before, remember on the one that you explored, what if we made this one 4 and this one 3? And now you can see when I try to do this, there's only one place that it can be. It's only one place that it can be. So after you explore this for a while, we do an activity. First of all, how many triangles were you able to create? Many people said 2, and I find that strange. If you put the longest side next to the angle, that would be true, that you could have 2. But you could also put the shortest side there. And then so there's actually 3 different possibilities that you could make. Do you think that any two sides of one angle measure is enough to guarantee that the triangles could be congruent? Well, that's why we call it the SSA sometimes theorem. Of course, it's going to be true. And that's what we're trying to explore here. This was a homework question from section 6. And in it, we said, well, we know that this segment here is congruent to itself by the reflexive property. And we end up with side-side angle because we're told that this angle is congruent to this. And the question was, is this enough information to guarantee that triangle DBC is isosceles? In other words, if these two triangles are congruent by some shortcut, by CP/CTC, you could show that these remaining sides here, this one and this one, are congruent. And if these are congruent, and I'll put a little X here to make this X, then if these are congruent, then this is isosceles. We did not have enough information before to prove that these are congruent. Do we now? That's the question. Is this enough information? What do you think now? We'll come back to this. So in a triangle, suppose we know two lengths of two of its sides have the same measure and one angle that is not included between those two sides. This is the SSA or donkey theorem. If this is an acute angle, then there's 3 possibilities. One is that there could be no solution. That is, the second side could be, the side that's opposite the angle could be too short to make a triangle. So it's kind of like a moot point. But on the other two, here I've got a 4-3-3 or 4-3-4. And the first figure is moot. You don't even have enough to make a triangle. And these other two, this one where there's two possible solutions and one possible solution, what's the difference between those two? If I say it another way, look at this again. My angle is 43 degrees. That's the red angle that's given. Does it make a difference in deciding whether SSA is ambiguous or not ambiguous when the triangle with the given angle that's acute is obtuse? My answer is no, because look, this is obtuse and this is obtuse. And this one has two possible solutions and this one has one, so that wouldn't make sense. Would it make a difference in deciding the side-side angle case is ambiguous or not ambiguous if the given angle was a right angle or an obtuse angle? The answer is yes, but we'll look at that why. So anyway, everyone was assigned partners, and when you're a group, you're supposed to draw three different triangles. And I will do the first of these just to demonstrate for you how to do this, what I'm expecting you to be able to do. Here, if I have the first one that I'm supposed to draw is a right angle. So I'm going to draw this angle somewhere along this. Here's my angle A. It's 90 degrees. Now AB is 16. BC, which would be the hypotenuse here, could only be in one place. This is 20. And you could actually calculate what AC is. So this is not ambiguous. Not ambiguous. For DEF, we have the angle is 30 degrees. So I'm going to draw this angle, roughly 30 degrees. This is D. We have EDE is 15. So I'm going to draw this as 15. And then it says EF is 8. Well, if I do it over on this side, here I could have 8. Oh, I could also have 8 over here. So this is ambiguous. And then we have GH, which is also an acute angle. This is 50 degrees. This would be angle G. GH is 11. And HI is 13. I can't go this way because this is 11. But if I put 13, I can put it way up here somewhere. What do we notice? Anyway, we come out, we discuss this, and you upload a picture of your work. Here's the theorem down below. Only one triangle can be made, and the triangle congruence is guaranteed when you know that the longer side of the two given sides is opposite the given angle. So in the side-side angle situation, if this angle that is opposite the given sides is opposite the given angle is longer than the two sides that are given, you're guaranteed that it will be fixed. It'll be not ambiguous. Lesson synthesis. So we have the unique situation of the side angle side. We knew that that was a triangle theorem. This is also unique. If you have an angle and the shorter side, the longer side is opposite this angle that's given, that would guarantee that it's unique. If this triangle is a right triangle and the angle that you're given is 90, you're guaranteed that the opposite side is going to be the longest because it's going to be the hypotenuse. And folks, if this is an obtuse angle that you're given, you're guaranteed that the longest side is opposite the largest angle, so you're guaranteed that the longest side is going to be the longer of the two legs. So this would be unique. When it's not guaranteed is when the longer side of the two given sides is shorter than the side that is opposite the angle that's given. And this is explained in this situation. Here we have a right angle. The hypotenuse is going to be the longest side. It's opposite. It's the side that would be given. This is non-ambiguous. Here we have a situation that's definitely ambiguous, because if this angle is acute, if this is a right triangle or an obtuse triangle, this would be the longest side, which is the one that's next to us. I could put this E over here somewhere or over here, make these two different triangles. This is ambiguous. And in this situation, I have an angle, side. The side that is opposite the angle is longer than the adjacent side. So these must be congruent. And here's the summary. You can read through it. And I hope that you grasp this. This is really a significant and fun lesson. Good luck and success.